Now listen. Your first topic today is properties of lines of force. So write on the side heading in your book as well. Properties of lines of force. Properties of electric lines of force. Right on side heading. Now, topic looks very easy, but it's very important because every property can be made into a question and can be asked. They can twist it, or they can give you 4 options in which they'll tell you which of the following is not a property of electric field, or they'll give you 4 statements asking that identify all the properties which are of electric fields. Nevertheless, you will need to know all the properties, not the whole property, but at least the main sentence of that property. Now, some we have done in 11th, some we have done it right now, but all in all, you should know at least 7 to 8 properties which are commonly asked. Now look at the first property. Electric field lines come out of the positive charge and go into the negative charge. That was done in 11th standard. They go from positive charge to the negative charge. Means they go away from the positive charge and they go towards the negative charge. See the second property. Tangent to the field line at any points gives the direction of the field. Now that is actually the definition of electric line of force. Look at the definition of line of force above that and look at the line which is underlined. Just check. Can you see the definition of electric lines of force? What is it? Tangent to that point gives the electric field. And can you see the second point in properties? Can I say the second point itself is the definition of electric lines of force? Because tangent to that will give you the electric field. Now look at the third point of electric lines of force. They never cross each other because they are parallel along their journey. This also we have done in our 11th standard. Now look at the fourth point of electric lines of force. They are always normal to the conducting surface. Means what? They are always at 90 degree to the conducting surface. Now look at next point. Electric lines of force do not exist inside a conductor. Means they do not enter the conductor. Hence they will not form closed loops. Look at the next point. Electric lines of force never form closed loops because they never enter the conductor. Unlike magnetic lines of force, where magnetic lines of force are from south pole to north pole inside the magnet and from north pole to south pole outside the magnet. Unlike that, electric lines of force do not enter the conductor. They go away from positive and they go towards the negative. Point number 8, point number 7, not necessary. So point number 1 to point number 7, I want you to write it. Quickly tell me if you have any doubt. Point number 1. In that point number 2 is actually the definition of electric lines of force. Okay. All of these points were done in 11th, I hope, or if they're not done, you should write them right now. Next page, there are more points. But now write down from this page, point number 1 to 7. Start quick. Number 1 to point number 7. Once you're done, put a dot. Turn the page. This is a very important point to find the resultant flux. Okay, this is a very important point to find out the resultant flux, and this is electric flux. And they are saying electric flux, that is number of lines per unit area, is given by the formula E dot A. E dot A is actually, listen to this, it will be E A cos theta, correct? E dot A will be nothing but E A cos theta. Now, E into A, that means electric field into area, will give you the electric flux. And many times, flux is written as electric field into integration of ds. You know what is integration of ds? Closed integration of ds. Means integration of all the small surface area will give me the total area. Do you agree? Therefore, look at the formula for electric flux. Okay. The first thing is electric flux. Electric flux is given by the formula E dot A. Now, area is nothing but, the total area is nothing but closed integration of all the small surface area. Therefore, in future, if you see this formula for area, you should not get confused. Or many times area is substituted as closed integration of ds. That means electric flux is also given as E into closed integration of ds. In that, this means nothing but the area itself. Also, since it is E dot A, electric flux formula is E A cos theta. Okay, now that is the meaning of point number 8. This is the meaning of point number 8. Therefore, in your own words, remember, this is electric flux. Tell me, what is the formula for magnetic flux? Can I say magnetic flux was B dot A? Can I say magnetic flux was B dot A? Can I say magnetic flux was B dot A? Remember, phi equal to BA cos theta in magnetism chapter. Similarly, electric flux will be E dot A. There it was magnetic field into area. Here it is electric field into area. Okay? Right. In your own words. You don't need to write the definition. You just need to write the formula. Point number 8. Therefore, if I ask you what is the formula for flux in future, or if any question comes where you have to find out flux, the first formula that you should go to, actually this is not the first formula you should go to, but the first formula that you have seen right now is this. The actual formula you should go to is Gauss formula, which I will teach you today itself. That is the formula you should go to, but this is one of the main formula for flux which you got from electric lines of force. Now, if you see point number 9, can you check whether it is same like uniform electric field and non-uniform electric field? Just check. Point number 9, can you see the diagram? If it is equal magnitude and direction, can I say it is uniform electric field? If it is non-uniform magnitude and direction, it is non-uniform electric field. Remember that from 11th standard. What is the definition of uniform electric field? If it has the same magnitude and same direction, it is called as uniform electric field. If it is not having the same magnitude and direction, it is called as non-uniform magnetic field. Okay, so not necessary to write that, but you should know. Clear? Finish this topic, electric lines of force, let me know. Have you finished this topic, electric lines of force? Just let me know. Okay? Everyone? The next topic is called as electrostatic shielding. The next topic that you should write is electrostatic shielding. So I have told you that inside any charged conductor, the electric field will be 0. Correct? Inside any charged conductor, electric field will be 0. That is why during lightning, sitting inside a car will make more sense, because you will not get it inside the car, the electric field. Or very high sensitive devices are placed in such a box so that no field goes inside. Now read the definition of electrostatic shielding and tell me if you have understood what they are trying to say. See the paragraph. Electrostatic shielding is the phenomenon of protecting a certain region of space from the external electric field. Now, sensitive appliances and all that are based on this concept. And if you see down below the diagram, see point number 1. For this reason, it is safer to sit in a car or in a bus during lightning rather than stand under a tree or in open ground. Did you understand this? We have already covered this actually in the last class, but this is the concept of electrostatic shielding. Just check the diagram and you can check inside that hollow space, electric field is 0 since charge is equal to 0. Okay. So I want you to read that paragraph of electrostatic shielding above the diagram. Below the diagram also I want you to read it till point number 1. Till point number 1. Okay. So you have to start writing from electrostatic shielding and you have to stop at ground. That is point number 1. Start writing quick. This is your topic of electrostatic shielding. I'm telling you to write because exactly the same topic is there even in your 12th standard boards. So if the question comes for 2 marks even in boards, you have to write this particular paragraph. Start writing.